All right. Hello, everyone. I am Ellie. I'm a developer advocate at Pieces, and I am here with Mark over here, hopefully, in this direction. Mark, who are you? Can you introduce yourself really quick before we get started?
Yeah, absolutely. Hi, Ellie. Thanks for having me. I'm Mark. I'm the CTO here at Pieces. And then what do I do? So I write a good amount of code, but I also work very closely with the machine learning team to take some of their really awesome work, bring it into the infrastructure, write a lot of the infrastructure, and then also to communicate a lot of that vision with some of the product team.
Very cool. Well, for what we're talking about today is actually the newest LTM 2.5 release. So as of seeing this video, it should have been out for a couple days now, maybe. We're going to be talking to Mark all about it because he played a huge role in pushing all of those changes out, especially in regard to Pieces MCP server. And if you haven't heard of Pieces MCP server, I'll probably include some links underneath this video so you can learn more about it, but we will tell you about it here as well. So without further ado, what are you personally most excited for in regard to this LTM 2.5 release, and what should people know about it?
Yeah, so a couple things. The first thing is just generally across the board, major quality of life improvements with regard to some of these nano models. And I'm sure if you haven't heard about them already, they're really cool. Basically, what they're doing is there's a whole suite of features that are enable us to basically understand more of what you're looking for within each one of your different queries. And that's the first part of it. And then it kind of breaks up into a tree structure. So given a user's intent, are they talking about a specific time or a source, or are they trying to aggregate new content? Are they talking about a memory? So that is 100% the biggest thing. And some of these models they're still kind of in like the 1.5 cents. So they'll continue to get better. However, they are so powerful. And we're already seeing some of these initial breakthroughs and how they play together with some of the really cool data structures that are also included. So that second piece that I'm really excited about is we've layered in a ton of different relationships between all of your different materials. And when I talk about a material, this can be a number of things. This can be a conversation message, or it can be a code snippet, or it can be a memory, or it could be a conversation, or it could be a person or whatever. And basically what we're doing is we're behind the scenes using a lot of our local AI to create those associations and say, hey, these things are highly related. Let's go ahead and make those associations, as well as using clever traditional algorithms behind the scenes to also let us know that these are highly related items.
So basically, what I'm understanding about this new release is that people are going to be able to find all of these memories and relevant context much easier than before. And also, LTM 2.5 is going to be able to actually identify what matters more or more quickly. Is that sort of, in essence, what part of what's going on is?
Yes, so there's in my mind I break it down to a couple phases, but there's a couple different ones. The first thing is like first making sure that you have the right context.
Mm-hmm.
So and that's broken down into a couple parts. But the first thing is you need to make sure that you have your entire set, that somewhere in that set you do have the right context. So that's the first thing. The second thing is, wow, now that you have this massive set, how do I find that right bit of context? And then once you have that right bit of context, how can you cleverly provide it to any generic LLM, whether it's a cloud LLM or a local LLM, and provide a proper contextualized response? But all three of those things were nailed, and they're not perfect. There's always room for improvement, but greatly improved with the LTM 2.5 release.
It's interesting because recently on Twitter, someone wrote this really long review of Pieces. I don't know if you've been seeing that. But one person mentioned that one of the problems that we could be facing when building Pieces is something called context creep. Have you heard of that before? Do you know what that means?
No,
Yeah, I think from the context of the post, it sounds like Context creep refers to extra context that is not relevant to you at all, and then maybe that going into these summaries or into your answers when you don't want that. So that's something that I remember when I was talking to Sam about the nano models. We did an interview already about that. I'll link it below if you guys want to check out the nano model one. But from what I understand, it seems like the nano models are also working to avoid giving us all this extra stuff that we don't need, or providing that in these workstream summaries.
Absolutely. That's that. So beyond the first phase, there's that second phase. That's like, hey, once we're given that big set, how do we reduce it down to the right bit of context? Absolutely correct. That second phase right there helps reduce this problem of context creep. I never really had a name set to it. Oh, what do we call this at Pieces? Because obviously just working with these problems and solving these problems on a day-to-day basis, you're familiar with problems like this, but all these like new names are like popping up and all that.
And maybe the guy just made up the name, to be fair, but it sounded right. I was like, that's a good word for irrelevant information that creeps up on you and is just in there and wasting space, essentially. But also, I think it was Sam or Andreas that mentioned that when we actually are storing these long-term memories, they're stored in some sort of database, right? Mm-hmm. On your device.
Yeah.
And I originally, how I thought about it was that we were filtering the stuff out right away and just getting rid of all the irrelevant stuff. But I think that we're keeping some of it because once the nano models are improving, then they can actually go back and realize, oh, actually, that was important. Is that what's happening, or am I misunderstanding that?
It's actually the opposite. So we store everything, and then what we do is we retrieve the bits that we want. So for instance, let's say given a time range, let's say our initial entry point into the search space. So the first thing is that if you're trying to find a needle in a massive haystack, it's going to be really, really hard if you're working with the whole haystack. However, if you can start to take chunks of that and you're like, oh, or it's not in this chunk or this chunk. And then you can do that a bunch of different ways on a bunch of different metrics. It makes it easier and easier to try to find that needle. So we start with the haystack and we actually store the haystack. And then we break that haystack up with all of our different nano models to try to find that needle there.
Oh, that makes sense. Because why I thought that we were deleting things up in the very beginning portion when you first retrieve these or not retrieve them, but when you first kind of save these memories, is because I figured saving all of these memories would take up a lot of storage on your device, right? But then recently we've been talking about, I don't know if you heard, rewind is sunsetting. They are a memory thing, essentially. Yeah. And apparently per month they would store 16 gigabytes. I don't know if that's the right number, but it's close, of memory every month. And then I guess Pieces is 0.2 per month gigabytes. So that is a huge difference. So why is Pieces storing so much less data than something like Rewind?
Yeah, that's a great question. Well, there's two things. So you're actually not wrong. We do delete data because we could technically store everything if we really wanted to. The first thing is that we store everything on device. So in storing everything on device, you don't want to bloat the local device's memory, at least on disk, as well as when you're running your application. Both are problems. To solve the disk problem, the memory on disk, right now what we're doing is we have two metrics. However, so one of the metrics is basically time. So anything saved over, and these are numbers that we've just continued to expand as we're able to store things more efficiently and more performantly, and also be able to retrieve those and use them properly within any LLM. We've continued to expand that, but I think right now it's 3 months or something like that. I'd need to double check. I think it's anywhere from 8 to 12 weeks is what we start to then remove some of those older events. However, these smaller events that are getting removed weren't necessarily a part of any one of these memories. So it's a little complex, but what we do is there's multiple levels. So there's these micro memories, and then you can consider them like a roll up of some of these micro memories, which we call these activity summaries, workstream activity. That is a roll up of micro memories there. So past, call it 3 months, all those micro memories that have, one, not been used in a conversation, or two, not been used in a summary, have never been retrieved, have never been used. Therefore, we're cleaning it up, rolling it up, and shipping it. And then there's actually a number of things that we do to ensure that we keep everything as small as possible. And we don't, so the biggest thing that separates us from Rewind is that Rewind, as far as I know, stores videos, and they could also potentially be storing screenshots. And then I'm sure they're also storing all of the raw data that they're using as well. We don't store any of our data, and what we do is we take screenshots. But our screenshots, we don't store those. We use them temporarily and then we discard them because it's such a heavy material. And then we just store the textual values. And then from there, we actually do a lot of work with those textual values to make sure that, hey, for instance, if I'm sitting on a site or I'm sitting on IntelliJ or I'm just writing code, you're going to see a lot of duplicate text. And there's the first solution is like, it's a hard problem to stitch them all together and do all that. But we'll basically ensure that we only have the bit of text that's continuing to change so that we're not just like, all right, let's store all this, even though there's so much overlap. And then with that, what we're also going to do is we're going to continue to roll those up, those micro memories, and to say, hey, all these micro memories are really similar. Let's just go ahead and collapse them into one micro memory. So there's a bunch of strategies that we take, and those are only a few of them to keep memory as low as possible and keep one previous memory that you've seen on your disk really lightweight. And then also to keep any additional data that we're continuing to store as precise as possible so that when we're going to retrieve them, we can have as much context as we can while also having a smaller search space to look through.
You did mention though that OCR is improving a lot with this LTM 2.5 update. What is exactly improving about it?
Yeah, so there's a number of things. The actual core component of OCR is still, that phase is not really getting touched. It's all actually the post-processing. So after we've taken the screenshot and then after we've OCR the text, once we have that text, we do a bunch of different things. And I don't want to say too much because
Bunch of
a
secret
lot
things.
of it's IP, but back to some of those strategies that I had mentioned before of making sure that you're not duplicating all of your text, making sure that you're rolling up some of that text into similar micro memories. And then also to even before that, there's even OCR can be, depending on what model you're using or what strategy you're using to OCR, your text is not going to be as good. So if you have a bunch of funky, wonky characters and you feed that directly into an LLM, one thing, even just feeding that raw text into an LLM, they're going to get confused. If you're with a really big LLM, maybe they're not going to get as confused as a smaller LLM, Phi2 or another local LLM. And then also to the second part of that is if you have really junk text and you're using, whatever user query or something else or a topic or, related questions to be able to go ahead and retrieve that stuff right there, it's not going to match nearly as well as if you were to have something that was a human readable text. So there's too many things that could be a whole chat.
It could be a whole chat. I did ask you these questions for a reason though. I did get a little bit down the rabbit hole here, but I do want to talk about Pieces MCP server, but I wanted people to understand what's actually going on with Pieces LTM in the background. Otherwise, I don't really think it would make sense talking about Pieces MCP, if that makes sense, because they wouldn't even know what Pieces LTM is doing, right? So
a little I kind of jumped around a bit, but the main phases are basically just within the LTM flow. An automatic phase is screenshot, text, persist, and then retrieve, all of which happens on device.
I want to go back to that in a second. I'm going to compare that with something else, but I want to know, can you tell us what is an MCP server really quick? We're going to jump into the Pieces MCP rabbit hole here.
Absolutely. And I actually preemptively looked this up online because I thought this was a funny definition. I think it's true, but I also would tweak it in a way. But basically, an MCP server is a standardized API, and I believe it was created by Anthropic, and then it's just being widely adopted across the ecosystem. So it's now become a standard where basically you define a specific schema to be used by any sort of LLM via tool calling and all that sort of fun stuff. And a tool call in a nutshell is basically just some sort of task that some sort of AI agent determines that, hey, your app is perfect because this is how you described your tool. This is your schema that you're going to take in, and we are going to provide you with that data. You're going to do some processing to it and then return a form, some sort of generic format that I'll be able to ingest and use as an LLM. So TLDR, this is the dictionary definition. Basically, an MCP server is a component of MCP protocol, a standardized way for AI models to access and interact with external tools and data sources. And I would actually modify that. It doesn't necessarily need to be an AI model. You could use MCP without an AI model. So for instance, if I wanted to go ahead and retrieve memories from a different application and wanted to use Pieces to do that, all I'd have to do is just listen to Pieces, and then I could just have a button click and I could just call a request directly to Pieces to get some information back, and I could get it and use it and display it or do whatever I want with it for retrieval or any sort of fun stuff. So I don't think it's 100% not limited to AI.
One thing that kind of confused me when MCP first became a thing a couple months ago, how we have Pieces SDKs and people build projects on top of those. And for example, one person on Twitter recently posted that they were planning or are already building some different timeline view of Pieces themselves. And so it has memories, but it's sort of like a line in the middle with some circles, and it's like a timeline of what they were doing essentially. So I'm wondering, what is the difference between using our SDKs and using, for example, Pieces MCP server? Could you do the same thing, or what is the difference here?
So the difference is that there really is nothing much of a difference. The only difference is the feature set that we have available via the MCP server. But at its foundation, they're both just ways for you to access your data that's stored within Pieces. That's it. And right now, there's only two. One, to be able to create a memory. And creating a memory isn't going to create these micro memories I was talking about, but it's actually going to create that workstream activity. So that kind of summary. And that's what we actually prompt for in our tools. So for instance, if you're an LLM, you are going to provide us with a summary of some sort of memory in a markdown format, versus if you are like a plugin developer, you have flexibility as long as it meets our specific schema. As long as it meets our schema, it's gonna create a memory. And there's no problems with that on our side, and it'll go through the proper flow and all that sort of fun stuff.
That is really cool. So besides like people going off and building their own projects, how can people actually use Pieces MCP server? In what tools can they use it?
Personally, I use the most in Cursor, and I find that it's the most consistent in Cursor. However, I know with the CLI agent, we actually set up a tunnel. So let me back up. There's two ways to interact with an MCP server, specifically in all the different tools out there, Anthropic or Cloud Desktop or Cursor or VS Code or Windsurf. Or one way is to provide a URL. So basically, you can just provide a specific URL, which is like, for instance, for PCOS, it's going to be localhost 39300 / the MCP route with a specific schema. And that will work and that will communicate. And then there's another way versus std.io communication. So basically what it's going to do is it will open up some sort of like a terminal command or a CLI or executable that basically you could either one set up on a server and you could basically kick it off. And then you could just set up those listeners. Or another way to do it, and how we've done it here at Pieces, is we basically just have our CLI agent open up an MCP connection so that basically if you provide your specific command to execute commands from those different, Claude desktop is one of those, then basically it'll funnel all of its requests through the CLI. And then the CLI will make those requests with Pieces. So it basically acts as a middleman. So there's two ways, basically HTTP or std.io.
But one of the things that you mentioned to me about the difference between the and the LTM 2.5 release is that now we're generating memories through Pieces MCP versus, I guess, not doing that. Because when I think of Pieces, I'm thinking like Pieces OS is running in the background all the time, getting these memories. But why would we need to generate them through MCP if we're already getting all the memories from everywhere?
That's a really great question. The reason is basically because, well, one, as a user, well, as Pieces, as a developer, it's quite difficult to be able to capture all of those sequences and be able to roll them up into, okay, here's what you were doing. Here was how you solved this specific error. Here is how you solved this specific thing. There was maybe multiple things in there. And then you could find yourself with a summer that's doing multifaceted things, which is totally fine. And then you can ask about that summer and you can pick out that error, or you can pick out that feature, or you can pick out that note or something for later. However, Pieces MCP is a really great way to create hyper-specific memories that's contextualized based on, so for Cursor, your whole workflow. So for instance, I could say, hey, create a memory based on this feature that I just added. So then I can basically say, hey, I'm creating a memory, but I'm having this memory created based off something specific that I explicitly said to create off of, versus us trying to guess, trying to say, hey, here's what you were trying to do. And we're still working towards that problem of fully automating that system. However, MCP, and specifically the create memory, will just give us a leg up on it. And a lot of that stuff too, behind the scenes, is powered by, it's actually, there's not a lot of huge challenges with the MCP server. And I know that was one of your questions, so I'm sorry to steal your thunder. But that's actually, so a lot of the components that's currently being used are just components that are used in our flow in general. So adding some of these features in is just like drop-in, just like picking tools off the shelf and just assembling them in the right way. However, the biggest challenge is not necessarily with our own stuff, but rather the tools that interact with our stuff and the consistency across those tools.
Do you mean like the LLMs, or do you mean different IDs or different Chrome, stuff like that?
Both. Because just because you have a great LLM on the client side, it doesn't mean that you're going to be able to pick out the proper tool to use, one. And then number two, that you can, specifically if you're using an LLM to create all this data, that the data is going to be any good. And then two, and three, actually, matter of fact, three, that it fits the proper format. So if you don't pass in the proper format in an MCP tool call, on the server side, it's not going to match our form. We can't coerce this in any sort. We could potentially coerce it again, but we risk also messing it up even further. So that's actually the biggest challenge in my mind, is that you need to, just because you have a client side LLM, you need to have proper prompting. You need to know when to call the tool. You need to make sure it fits that tool call specifically. And that's a challenge for client side, and server side could absolutely also help with this. But there's definitely decisions based on prompting, choice of LLM, like when to call it, and then when you do call it, what's the data that you're passing over, and then also the quality of the data. So
Gotcha. I feel like we could do a whole talk about all the challenges that come with building one of the first of its kind, I guess, of a memory tool, because I don't think these things really exist besides recall and rewind, but I think ours is the coolest still. And I'm pretty sure we have the longest memory. I don't know how long their memory goes back, but I'm betting on us more than them. So I do want to ask you one thing that I'm always really curious about. When has long-term memory saved you or has helped you in your workflow? One of those aha moments where you're like, oh my God, thank God, this is still here in pieces.
Absolutely. I actually ran into a case last week that I was super helpful. Basically, what I did, and it's tricky because you need to train your brain with MCP, unfortunately, at least to create the memories. And that is specifically like, so for instance, I use Cursor and IntelliJ, and I kind of use them interchangeably. But the case that I was working on is I was basically solving an issue. And what was it related to? Either way, I was solving an issue, and I, in my mind, said, hey, I've been working on the MCP server. Let's give this thing a try. So I had it create memory for me, and it created pretty good, pretty high quality memory, had some code snippets, had a great summary, and so on. Created it, is in my activity feed. And that's the first part, is knowing when to save a memory. And it can be, you have to train yourself to do it. However, if you use Cursor or some of these MCP tools frequently, it can actually help tell you when you should create a memory based on some of the prompts that we've done on our side as well. Basically says, okay, and these are all public. But basically it says if you run over or if you run into an error or a stack trace or a solution to these problems, or you're doing a feature, or if you're doing something repetitive, go ahead and create a memory. And it's a bit more comprehensive than that, but that's the gist. Then it'll attempt to create memory for you. So that's really awesome. However, I find that I typically just have to conceptually be like, create the memory based on, it'll go ahead and create that memory. And matter of fact, I ran into a very, very similar solution or a similar problem, a similar issue that I had ran into in the past. So I literally took my same error that I ran into and I said, hey, ask Pieces how to solve this error. And it was able to ask Pieces via a tool call to query my memory. And then it was able to go ahead, retrieve that specific memory or summary that we had created a couple days ago, ingest it into Cursor, and then create that, that LLM response to have my specific solution for me. And then it was able to say, suggest a solution right in the app. And I basically just accept, good to go. This is crazy. Just like absolute eureka moment, which was wild.
That is awesome. I love that. And I am so excited to see people having those moments with Pieces, especially when they post about it and they're like, oh my God, I just talked to this person and had this meeting, and then I was doing this and then I was doing that, and then Pieces knew everything about it. And also the deep linking, when we introduced that, I thought that was super useful because people definitely don't remember all of their links. I don't know if you've seen that meme with a million tabs open in Google Chrome and then you accidentally close them. I feel like, I don't know, maybe I just made that up in my mind, but I
No, that happens to me all the time. All the time. And also too, in 2 days, I could have remembered this solution, no problem. But the real magic is like when you're jumping across multi different features and functionality and so on, and you jump on into a whole side quest a month later,
Right.
come back to a different feature, and then you're running into these same problems that you ran into a couple months ago. Can you create those solutions without having to go through the same flow, either one by manually debugging it, running it with a debugger, adding your print statements, blah, or trying to generate a response or trying to get another response, but rather to having those solutions already stored for you.
It's absolutely, it changes the way that people work, I think. And as Pieces gets better and better over time, we're going to be seeing some really crazy things, because I think also we just happen to be in the right spot where people's memories are getting worse over time. So I think people do need a second brain. And Pieces seems like it's going to be the perfect second brain for people. So I'm very excited to see where we go next. But I really appreciate you being here and talking to me today about all of the changes with LTM, the nano models, the MCP stuff, and your thoughts on it. So I really appreciate that. You have any final words? You want to shout out anything?
I don't necessarily think that people's memories are getting worse. However, I think like yay, nay, but the reason why I think that Pieces really shines is because the amount of data that we're ingesting is just far more than what we were ingesting years and years ago when I was debugging with not only print statements and debugging, but also to finding those solutions on Stack Overflow. I was solving problems that I can solve now in a day that would have taken me a week. And now a day can take me an hour. So that basically what I can do now is I can solve a week's worth of work in one day. So how am I supposed to, and we are humans, we have our limits. I personally, I believe that there's no scientific proof, or maybe there is, but I believe that we do as humans have a data capacity. And also to a lot of what I was taught as a software developer is to half remember and look up the rest. You memorize everything, you'll lose your mind. So I think that that's where Pieces kind of comes into play, is that just like you were saying, Ellie, we're that second brain.
Yeah, the second brain that's going to save the day, I think. Especially, I agree. I don't know if people's memories are getting worse. Maybe it's like you said, this just the amount of information that we're exposed to every day is just so much that our brains could not possibly remember it. Maybe a couple hundred years ago, you're just walking outside and you have a lot of time alone with your thoughts. So maybe people would go over things more. Now we're looking at screens and consuming information every 10 seconds, a new thing pops up. So I am excited to see Pieces, the second brain, take over. And I hope everyone downloads it and tries it. And especially with this new update, it's super nice. And we have a new onboarding experience, which is way better. So definitely go download it and try it for yourself. And let us know in the comments if it is going to be a second brain or replace your brain. I don't think it'll replace your brain, but it will definitely help. All right. Thank you so much, Mark.
No problem. Thank you, Ellie. Bye.